Okay, welcome back. So ang ating next topic ay ang tinatawag natin auxiliary space complexity. So ano nga ba ang auxiliary space? So auxiliary space is or also known as stack depth or basically it's the additional memory or program stack memory kasi may iba-ibang types of memory sa computer. So it's the additional program stack memory that we need in order for the algorithm to do its job. So most probably for your previous na algorithms na encounter, yung mga sorting, etc., usually wala naman na silang additional space na kailangan. But recall, for recursive functions, whenever we call an additional function, nagpapatong-patong to sa ating program stack. So tumataas yung memory na kailangan natin. So auxiliary space complexity, similar to time complexity, describes yung growth rate ng ating auxiliary space na kailangan para mag-function yung ating algorithm. So similarly din, gumagamit tayo ng mga asymptotic notations like yung omega, theta, and yung big O notation for the analysis as well. And nag-a-apply yung same rules natin wherein mga coefficients usually pwedeng tanggalin and kino-consider lang natin yung biggest growing term to simplify things. So, ayan, for an example, yung sa factorial, for example, factorial of 5, sige, dun tayo sa GIF na hindi gumagalaw. Starting from main, tatawagan natin si factorial of 5, and si factorial of 5, tatawagan niya si factorial of 4. And notice sa program stack natin, whenever we call a new function, dumadagdag yung memory niya dun sa ating stack. So pag tinawag si factorial 3, mag-a-add siya. So bakit hindi sila natatanggal? Kasi hindi pa tapos si factorial 4 pag tinawag mo si factorial 3. So hindi pa natin siya pwedeng tanggalin sa program stack. So waiting for the base case, pagdating sa factorial 1, dun pa lang tayo matatapos. Or I guess matatapos yung recursion. So when factorial 1 finishes, it returns 1 and dun pa lang siya mawawala sa program stack. Then, pagtapos na si factorial 1, tsaka pa lang matatapos si factorial 2, tsaka pa lang matatapos si factorial 3, and so on and so forth. So, during the course of the execution of factorial of 5, we take up some space na proportional doon sa dami ng recursive calls natin. So for factorial of 5, we can say na ang ating space complexity ay linear or O of n. Since, yun nga, for example, if we get factorial of 10, it means 10 calls or 10 recursive calls to factorial yung laman ng ating stack. So, well, looking at it this way, parang kinakount lang natin yung mga recursive calls. So, ganun din ba when we consider ito, yung ating binary na function na nagsisplit? So, medyo, I guess, iba yung magiging itsura niya. So, let's look at yung ating visualization over here. So, start natin sa pinaka-tok-tok. So, similarly, magko-call tayo ng binary na function. Binary 3 in this case. Si binary 3, tatawagin niya si binary 2, si binary. And notice here, si binary 2, medyo mas malaki siya kasi kailangan niya ng additional memory to store yung ating temporary na variable. And then si binary, so yun, si binary tatawagin niyo sa binary 2 na merong kasamang storage. Si binary 2 naman, tatawagan niya si binary 1 and with additional storage pa. So parang medyo lumalaki siya dito. So mas malaki ng konti si binary 1 kay binary 2. And then lastly, si binary 1, tatawagin niya si binary 0. And siya na yung pinakamalaki kasi 3 characters na yung nakastore. And then we can continue yung ating pag-execute. So once the function is finished, pwede na natin siya tanggalin from our program stack. So pagdating niya kay 000, pwede na siyang mag-return. So ma-free up yung memory before malagyan siya ulit to call yung pag-print ng 001. And then actually, we can parang fast forward yung ating animation or in execution. And notice na parang hindi naman lumalampas yung memory natin dito sa ating line. So, kaya rin tinatawag na stack depth yung ating auxiliary space complexity kasi notice that yung isang path from our original function hanggang doon sa dulo is yung ating depth. And yung isang path na to, yung memory consumption ng isang path, yun yung ating kino-consider as our auxiliary space na requirement. And doon natin mapupulot yung complexity din. So, ayun, looking at it here, we can actually, so we can basically tabulate yung memory consumption natin for a recursive function by tabulating lang yung sa isang path from the root to the deepest level or yung ating at depth level. So look at it here. Yung initial na call natin will be some constant C1. And the next level will be some constant C1 plus additional space to store yung temporary na variable natin na nagsustore ng current na binary number na tinitignan. So yung C2 na to, lumalaki siya after each function call. As you can see here. So dito 1, dito 2, dito 3. And eventually, pagdating natin ng n digits na number, meron tayong n times C2 na term here for the memory. So, kailangan natin i-add lahat na ito. So, pag in-add natin sila, well, I guess pwede mo rin muna sabihin na per level, nag-add tayo ng KC2 na memory dun sa ating program stack. So, ayun, similar dun sa ating recursion tree na analysis, kukunin na natin yung summation per level, which is K times C2 plus yung C1 dito sa pinaka. So, ayun. We have D times sa C1, kaya siya meron ganyan, and then K times C2 from 0 hanggang, actually D, or actually yun, more appropriate, this is from 0 to but we know yung D natin from our earlier analysis sa recursion tree, D is equal to N. So, D is equal to N. So, pag kinuha natin yung complexity overall, this first term is just O of N. And the second term is summation ng isang arithmetic series kasi this is C2 plus 1C2 plus 2C2 plus 3C2. So, arithmetic series lang yan from 1 to ... N C2. So yung simplification niyan is n times n plus 1 all over. And with that, we get yung ating highest increasing term as n squared. So yung ating memory complexity for our function binary is O of n squared. So, ayun pa. So medyo similar lang siya sa time complexity, pero nag-iiba ng konti yung ating context. So, sa time complexity, kailangan natin consider lahat ng lumitaw sa ating recursion tree. But for memory, we only need to consider one path. And that is a path from yung ating root hanggang doon sa kanyang deepest level. So usually kasi, well, this is, it's pretty unusual na yun din, nagsiscale yung ating memory. Pero actually, hindi naman siya ganun ka-unusual, pero less common lang, I guess. So normally, kung constant lang yung space natin for each function call, kung ano yung depth ng ating recursion, yun na rin yung space complexity natin. So actually, yung minsan ang kinoconsider lang yung recursion depth and hindi na kinoconsider pa yung other things. So yung depth itself siya na is more than enough to be an indicator ng memory consumption ng ating function. But in any way, para mas kompleto of course yung ating discussion, kinoconsider na natin yung buong actual na space complexity. So yun, since alam niyo na yung time and space complexity, we should already be able to accomplish yung ating summative quiz or yung graded quiz for the week. So, medyo summative pero wala siya sa dulo kasi meron pa. Although wala naman na i-quiz pa for here. So, medyo coding exercises. So, yun. Good luck sa quiz and see you again.